Good morning, everyone. Welcome to the 16th Urban Mobility India Conference and Expo 2023. It's a high pleasure for me to introduce the chair for this session, Professor Manoj M. Professor Manoj M has done his master's from IIT Guwahati, and he holds a PhD from IISc Bangalore. Professor Manoj's areas of interest are transportation planning, activity travel, demand modeling, long-term mobility decisions, econometric modeling, built environment, and travel behavior. So I would like to invite Professor Manoj M on the stage to proceed with the session. Before that, I would like to request the authors that you have 10 minutes for presentation, followed by a 3-minute question answer session. Okay. Professor Manoj M, please.
I'll do it from here.
Okay.
Thank you, Mustanshir, and good morning, everyone. Welcome to this session titled Travel Demand and Transport Planning. We have 6 interesting papers in this session. I think 3 of the others are already here. I guess others would join us soon. Without wasting time, I would like to, set out the rules for this session. We have 10 minutes for the presentation, followed by 3 minutes for Q&A. So, although we encourage, questions, we need to ensure that, the questions are really short, and the answers also let it be short, and then we'll give a time during the tea break for you to interact with the authors and the attendees. With that, I would now like to invite the first presenter, Anurag Sonkar, paper ID 92, who will be presenting his paper titled Development of a GIS-based approach for spatial disaggregation of emissions from road traffic. And over to you, Anurag. And I would like to highlight one thing, that I'm also parallelly looking into another session. So I'll be there for 15-20 minutes, and I will join you back. In the meantime, Mustanshir would compare the session, okay, on my behalf. Okay, thank you. Over to you, Anurag. You have 10 minutes, and you can see the counter here. Okay, the time is marked here. Okay, so for your session. Yeah.
Good morning, everyone. My name is Anurag Sonkar. I'm currently working as a PhD research scholar in Center for Transportation Systems, IIT Roorkee, under the guidance of Professor Bholaram Gujar and Hemant Kumar Sumansan. So I'd like to thank you for giving me this opportunity to just present my topic here in this conference. So my topic is development of GIS-based approach for spatial disaggregation of the emissions from road traffic. And these are the contents which I'll be discussing. So basically, for starting, I can say with the rapid increase of urbanization and motorization, the air pollution is also been constantly increasing, which means that the air quality is constantly degrading, and vehicle emission is one of the major factors or major contributing factor that is causing the urban air to degrade. So we can see that the Indian transport sector basically is responsible for 13.5% of the total CO2 emissions, and the transport sector includes the roadways, railways, and domestic aviation, and out of that, the 90% of the emissions are basically from the road transport. And this emission from road transport basically includes the various type of pollutants, and one of the pollutants is the heavy metals. So heavy metals is the main majorly like a health concern because of its toxicity or carcinogenic properties, and they have the tendency to just be suspended in the air since they are not degradable. So they suspended in the air, so they are basically causing the risk for human health. And basically the emissions are categorized into 2 categories. You can see that from transport emissions, the basically are exhaust emission, non-exhaust emissions. Exhaust emissions are basically that tailpipe emissions, and the non-exhaust emissions are basically the brake wear and tire. Brake wear are the brake wear emissions are due to the friction between the rims of the tire and the brake pads, and the tire wear, the emissions due to wear of tire. And the heavy metals which are being emitted are the chromium, nickel, lead, arsenic, and cadmium. So for this, we have chosen the Delhi as a study area because Delhi is one of the most polluted cities in the world, and these are the basic features. So the road network of Delhi is basically divided into four categories: the highways, major roads, minor roads, and residential roads, which are primarily used for local transit. So in this study, what we did, we have graded the whole Delhi city road road network into 1 by 1 kilometer. So in this map, you can see uh, the whole of the area of Delhi, the road network is being graded into 1 by 1 kilometer. So the emissions are being distributed considering the road density as the proxy. So road density is defined as the number of kilometers that's being included in that particular grid. In the methodology section, I'd like to say that once again that the emission are distributed over the Delhi, and this is basically the methodology which have been adopted. The number of vehicles registered are taken, and they are being classified into based on the fuel type, vehicle type, and the phasing out age of the vehicle. And the vehicle kilometer traveled by that vehicle are being noted. And with the help of emission factors, we are just estimating the emissions. So for especially disaggregating the emissions, we are using the ArcGIS model builder, which is one of the features in ArcGIS. The model builder that I will discuss in the later slides. So after estimating the emissions using the GIS, we are just disaggregating the emissions, road traffic emissions to 1 by 1 grid over the megacity of Delhi. So this is the basically data. This vehicle categories are being divided into 7 categories and further classified based on the fuel type, technology type, and the vehicle age, and vehicles kilometer traveled, and the on-road vehicle fleet and the annual kilometer vehicle travel are noted from the survey which was undertaken by the suffer inventory, emission inventory. And these are the basically equations which we are used because we have adopted a bottom approach for estimating the emissions. It is both the exhaust emission and non-exhaust emissions. So it is where non-exhaust emissions are basically the product of the vehicles and the vehicles traveled multiplied by the emission factor. And for exhaust emission, we have adopted a tier 1 approach based on the emission inventory guidebook of EEA, and which signifies that fuel specific emission factor are being used for estimating the emission of heavy metals. So here we are estimating the fuel consumption using the fuel consumption factor, and this fuel consumption factor FCF is basically dependent upon the average speed of the vehicle. So after estimating the fuel consumption, this multiplied with the emission factor to estimate the emissions of heavy metals. So here you can see, since I told the fuel consumption factor is the function of average speed of the vehicle. In the graph, you can see in the secondary axis the vehicle speed, and the x-axis is the number of vehicles based on the categories of fuels. And for each speed that is being taken at the average speed, you can see the fuel consumption factor we have calculated. And basically, these are the equations which are suggested in the Coopert methodology. So using this equation, we have calculated the fuel consumption factors. And these are the emission factors for which we have taken for both non-exhaust emission, that is for brake wear and tire wear. And for exhaust emission, we have taken the emission factor of two methodologies. There's one from Coopert, that is computer program to estimate the road traffic emissions, and the second is the emission inventory guidebook. And due to uncertainty in the emission factor, because very few studies have been there which studies the emission factor of the heavy metals. So to get the clarity, we have taken two emission factors for this exhaust emission. And since this lead emission factor is not available, so for that we have considered the this suggestion from the CPCB guidelines. So after the estimating the emissions, there comes the role of the model builder, which is one of the unique tools in ArcGIS. So instead of going all the tools or different geoprocessing tools, what we can do, we can just combine them and take just create a one single tool. So for any geographical region, for any resolution, we can simply enter the data that is basically the administrative boundary of the region, and secondly, the road network of the region. So just using this two data and the estimated emissions, we can distribute the emissions based on the road density for any geographic region at any resolution. And these are the results which we have got. So basically, you can see we have generated a map for Delhi city at 1 by 1 kilometer. So you can see that majority of the emissions are from the northwest of Delhi, and this minor or least emission is from the central Delhi. So basically, it considers the area. If we go for the district-wise emissions, northwest is the highest. But if we go for the intensity of the emissions, you can see the east of the Delhi is having the major emissions, or you mean the center of Delhi or the east of the Delhi, that considers as being that are the hotspots, which I can say. Similarly, for the exhaust emissions, we have calculated the emissions for from the exhaust sources, and here also you can see the same thing. Since majority of the road density or the congestion network lies in the east of the Delhi and central of Delhi, and few of the grids are there in the northwest, west, and the this South Delhi. So all of these are contributing majorly towards the road traffic emissions and the heavy metals. So one thing we have found that in spite of using these two emission factors, basically this there might be difference in the values, but the relationship with what we can do, we can infer that all the relationship that like we are getting, that two-wheelers are the majorly polluting and followed by the cars. So here it was found that copper was the major contributing heavy metals, followed by zinc. In the conclusion, I would like to say that in this study, the emission inventory was generated at a special resolution of 1 by 1 kilometer for Delhi city, and heavy metals emission was estimated using bottom-up approach. And the contribution of this study is that we are integrating the methodology from the WAPI, that is methodology based on the emission estimation on Indian context, and the methodology for estimating the emissions or emission factor we are using from the cohort methodology, and to estimate the this heavy metals from on-road emissions, we are developing the model builder. In this, we are developing a customized tools. So that tools may be used for any city, for any road network. So that is the main contribution of this study. And it was discovered that this copper and lead are the main primary or emitted metals from bake wear and tire wear respectively. So basically, because of the emission factors which are being considered in this study, there might be uncertainties because in the Indian context, we are not having the emission factor. The latest emission factor which was prescribed by ARI was in 2009 or 10. So that suggests that basically we need to just update the emission factors based on the Indian context. So that we can have an accurate or a detailed estimate of all the emissions. So this study will help to find out the basically hotspots which are being there in Delhi. So we can just prioritize or define the mitigation strategies to reduce the emissions. And these are the references. Thank you.
Thank you, Anurag. So we have a question answer session for 3 minutes. If anyone has any question, he can ask the presenter.
Hi, good morning. My name is Manraj from Unitrans. A nice presentation.
Thank you.
I was wondering that if I understood correctly, the road density is an input to your emission calculations.
Yes, sir.
Right?
Not emission calculations, basically that we use as a proxy to disaggregate the emissions.
Okay. So exactly how did you estimate road density from the, let's say, I think you use the
Yes, sir. I've used basically some geoprocessing tools in GIS. So the idea of this calculating the road density for grids is that this basically the shapefile which you are inputting in the ArcGIS, that is basically a line type shapefile. So line is basically a series of points. So what I did that I just break that line into series of points into 1 by 1 meter. So the I counted the basically the points in that particular grid. The number of points which are in the lies in that particular grid, that gives the road density of that particular grid. So, for example, if 15,000 points are there, and so then it can be said that 15 kilometers of road is there in that particular grid. So, on the basis of that, we are disaggregating the emissions.
But are you able to incorporate the composition of traffic in that grid?
Not exactly the composition.
Okay. Is that a limitation of this analysis? Because when you say East Delhi is one of the most polluted, it could be,
Yes,
of course.
yes, sir, yes,
But
sir.
the composition of traffic is very different
Yes, sir,
from,
yes, sir.
let's say,
Yes, sir.
other parts of Delhi.
So, sir, basically, that is it can be called as a limitation because basically we can't monitor the road fleet or road traffic in every grid. So, there are some studies which are calculating the number of vehicles in that particular grid. So, that is also based on the length of road in that particular grid. So, if we estimate the emissions or disaggregate the emissions based on the number of vehicles or number of kilometers in that grid, so basically these two are the same only that I've verified from my calculations. That if I just count the number of vehicles in a grid, or else if I do a special disaggregation of emissions based on road density, so both are results are quite similar.
Okay. Thank you.
Thank you, sir.
I have another question. I'm from Symposium. I'm with the Delhi Metro. Like Manraj rightly pointed out regarding the spatial density of the roads that you have considered, I have 2-3 quick queries
Yes, sir.
about what was the level of the roads which have been considered. Have you also considered the residential roads in this while calculating the road density?
Yes, sir. We have considered all the basically broadly saying that we have considered 4 categories of road, that is highways, major roads, minor roads, and the residential roads.
And say suppose a car moves from a residential settlement to a major connecting road, but that does not represent in totality the emissions. Say it will move out of the residential settlement in say 5 minutes, and it will take say 45 or 50 minutes to travel on a little more higher service road.
Yes, sir.
And while being on that road, there are stop and go conditions throughout the city.
Yes, sir,
and
yes,
it
sir.
has temporal variations.
Yes, sir.
And how do you plan to cater to those emissions spatially? Secondly, one more thing is the hotspots that we have seen, say East Delhi or say Faridabad or say around Delhi Gurgaon border. So I also want to know one thing as to how do you plan to disaggregate the freight movement and the private vehicles, as the road density as a proxy does not take into account the freight movement of the
Yes, sir.
vehicles.
Yes, sir. Correctly. The freight movement is not considered in this study. And basically, if I to answer your first question, for that we have to go for precise data that we need to just define the emission profile of that particular vehicle. So when we are considering city level emissions, then this detailed estimate is not there, or detailed data is not there. So for what you said that you find it pointed out that a car is traveling from residential road and is just connecting to major roads. So for that, what we can do just we can go for a macro level study, and we can just give a model that how that particular emission or the emission profile is being working out with the different kinds of vehicle category, you can say. Basically, it's not only the car, because it depends upon the what type of car it is, and what is the fuel type and what is the technology type. And secondly, the emission hotspots. In this study, we are not considered the freight vehicles. And in future scope, we are just exploring all the allocation factors or the proxies, which can be used as the proxy for disaggregating the emissions. So basically, we are looking forward to use population density and the level of extent of the urbanized area So out of these three emission factor which I've finally found to estimate disaggregate the emissions. So for precise estimation, we need more detailed data of that all the road network, since we are estimating it as in a very fine resolution. Okay, so in that way we can use this limitation only.
Just one more query.
Yeah.
Like you showed in your slides, you have used average vehicle speeds for different classes of vehicles for estimating the pollution emissions.
Yes,
I just
sir.
want to know how that value has been calculated, the average speed.
That is taken from the literatures, and from in the literature they have defined, they have taken a sample data and they have just observed the vehicle speed based on the vehicle category. So that data we have taken. Thank you.
Thank you, Anurag. Is Sania Gulia here? Okay.
Okay.
Thank you.
Thank you very much.
So, on behalf of the chair, I would now like to invite Sneha to present her work, Viability of Water Transport for Passenger Movement in Kochi. Sneha.
Good morning to all. I am Sneha and I have currently completed my Masters in Transport Planning from School of Planning and Architecture, Vijayawada, and I'm working with the company Lee Associates right now. So the research that I did was on the viability of water transport for passenger movement in the city of Kochi. So a brief introduction to the study area. Kochi is a city in Kerala, which is having water bodies present, and it is one among the very few cities in the country that is having the possibility of having water transport in the city. So the reason for which I took the study was that water transport is one of the most sustainable modes of transportation that we have at present. Also, one among the cheapest modes of transportation that we have in present. And before the early 2000s, in the city of Kochi, water transport was the only form of movement between islands, and all of the people were completely dependent on this mode of transport. But once the bridges were built after the early 2000s, it was seen that there was a drastic shift of ridership from water transport to road transport, even though the travel time by water transport was very less. So if we compare it with other cities, it is seen that water transport, people are not really using it much because the travel time is high. But in the city of Kochi, the interesting factor is that 2 to 3 times lesser than road transport travel time is what we see in in water. 2 to 3 times lesser than by road movement is what we see in water transport. So even then, why are people not using water transport? Was my aim, was the reason why I took this study, in order to understand what were the factors that was due to which this was happening. So my aim of the study was to critically analyze the use of water transport as a service for urban passenger transport in the city of Kochi. The study methodology that I followed was that first I've done a background study and inland water transport literature study. I developed my need, aim, and my objectives. Then for literature, I have divided into two different aspects. One was the spatial impact and second was demand assessment. In spatial impact, I did the buffer analysis, catchment area identification, and land use analysis. In demand assessment, I looked into the general demand assessment factors and the different mode choice models that are used at present. Then for data collection, site area selection I've done based on ridership. And then I've done two different surveys, that is the water transport user survey and the stakeholder and water transport operator survey. Under water transport user survey, again divided into three parts: demographic and socioeconomic profile, access dispersal trip characteristics, and the overall trip characteristics of the people in the area. From my access and dispersal characteristics, I've defined my catchment area, the existing demand assessment, and then I've done household survey, which was again a stated preference survey given to the people. And for data analysis, I've used a fuzzy logic mode choice model, and the parameters that I've taken into account are age, income, trip length, travel cost, comfort, waiting time, and travel time ratio. I have validated my model next, and then I have done a predicted model split, and then further I have done found the model share increase and the buffer area increase based on this predicted model split, and finally I have given the proposals. So in literature, I looked into the different mode choice models that are present, and then finally I selected the MATLAB fuzzy logic mode choice model because for my study area and the kind of survey that I am doing, this was well suited to human input, and it was more interpretable rule based, and it has more widespread acceptance, and also the accuracy was high. I have also looked into some other papers on water transport. One other gap identified was that water transport is not really researched much in India, and also there are not many papers present outside as well to have a complete understanding of what is the current condition. So I looked into some papers and that had done fuzzy logic mode choice models, and then I have selected my parameters based on that. Then for the selection of the stations in my study area, at present in Kochi, there are 6 routes running. And my basis of selection was that from the DPR for Water Metro, I have got the daily total boarding alighting data. And in order to have a complete, in order to be like that, I have taken all aspects into account. I selected 4 jetties. That is, one is which is having the highest boarding alighting, 2 stations that are having average, and one that is having among the least ridership. So this was to show that I have taken all of the different types of jetties into account. So for a basic station analysis, this is just about the Fort Kochi station. This is the major station in Kochi. So it has, the officer rooms are present there. It has 2 ticket counters, that is to 2 different routes. That is the Wellington Island embarkation and Fort Kochi, and to Waipin. The ticket fare is just 6 rupees. And if you have extra luggage that you're carrying, you have to pay an extra 6 rupees for that. So from the survey that I did, there is an almost equal differentiation between the male-female passengers that are there. The trip purpose of the people, 46% of the people that are using this station are tourists. There are 31% people that are traveling for work, and 23 people that are localized, that are traveling for shopping or sightseeing. And the occupation of the people that are traveling for work are government, private employees, students. So the peak hour that was observed on this route was between 8 to 12 in the morning and evening 4 to 8. And this is some of the images of the existing infrastructure of that station, and it can be seen that there has been no sort of infrastructure improvement done in the last 10 to 15 years. This was also a complaint of the officers working there, that the government is not really providing any sort of funds for them in order to improve the services. And so the final observations that I've seen was that the ticket counter is in dilapidated condition. There's fungus growth on the walls. There's not enough lighting. So in the evenings, people feel already water transport is considered to have some sort of safety concerns. So on top of that, not having lightings were also giving people security concerns. And the overall infrastructure of the building was in a poor condition. So next was the catchment area identification. So from my access dispersal trip characteristics, I observed that I took the maximum distance from which people were coming, and I have taken the wards of this maximum distance from which people were coming in order to define my catchment area. Then I've also got the land use from the officials. So it was seen that in all the stations, there is a major change in the land use that is proposed in the 2030 master plan. So if we can consider this station existing, there is 50% residential land use, and in the proposed land use, they have reduced it to 37%, and they have increased the commercial area. So most of the stations, they are trying to propose it using the TOD method, and the immediate catchment areas, they're trying to convert it into commercial areas. So the final existing demand supply gap I had done, which was, we can see that the peak hour demand supply gap at Ernakulam and Fort Kochi, the demand is much more than the supply, so that needs to be looked into. And this was just a desire line diagram of what are the major stations that people are traveling to and from. So then I have done the mode choice modeling. There were 4 steps involved. That is the model input and output parameters, setting up the membership functions, fuzzy rule base formation, and finally defuzzification process or validation of the result. So I had 7 parameters, which were age, income, trip length, travel cost, comfort, waiting time, travel time ratio, and my output was mode. And I have taken all the modes that people were using in those areas. So the input parameters, I have defined ranges, and then I have filled my form based on the answers people were giving me in these ranges. And then I have 37 rules defined, and based on these 37 rules that I defined, I have run my model. So I have validated my data set. I had 110 samples. My training data set samples were 91, and I got 91.2% accuracy for my training data set. For my testing data set, I had 20 samples and I had 80% accuracy for the same. Due to time constraint, I was not able to have a larger sample size. That's why I have only these many. And then for stated preference, I had given 4 scenarios to the people. So if we can see in the existing condition, the waiting time is 20 minutes, comfort is low, and the fare is 6. And I gave, based on my understanding and talking to the stakeholders, I developed 4 scenarios. And it was seen that scenario 2 is what people preferred the most in order to see a maximum shift to water transport. So scenario 2 is reducing the waiting time to 15 minutes, providing them medium comfort, and they were okay with paying a fare for up to 10 rupees. So the existing model share from the model, I've seen that there is existing 15% use of water transport in the catchment area, and using the scenario 2, it has been increased to 30%. So I have developed so we can see that these parameters, waiting time, comfort, and fare, if we change the situation based on these parameters, we can see around 15% shift to water transport usage. So the final conclusion of the study that I've done is that public usage of water transport is highly dependent on multimodal connectivity. So it's that people are finding it difficult to access the station. So if they can get some sort of infrastructure for the same, people are ready to use water transport because the travel time is much lesser than by road. So they are actually interested to shift to water transport. And there is a great amount of travel time saved. The major shift is observed that two-wheelers are the most number of people that are ready to shift, followed by auto and bus users. There is a high likelihood of increased ridership if the infrastructure is enhanced and the waiting time is minimized. And in the existing public transport services itself, interconnectivity showed increase in the modal share of the service, stressing on the fact that it is one of the most important factors that is leading to increased public transport ridership. So this interconnectivity, when we design it further, it has the potential to boost and make water transport a preferred mode of travel. So that was my study. Thank you.
If anyone has any question, he can ask. Please be brief. Just 3-minute questions.
Okay, so yeah, so I got the daily number of boats that are there every 30 minutes and the number of seats that are there in present. So it's like every 30 minutes there is a boat from Fort Kochi and it has a seating for 100 people. So I've took the supply for the overall 24 hours based on this, and demand data I got from ticket sales from the officials over there. So and then I did a comparison between the demand and supply.
Hi, good morning.
Morning,
Nice
sir.
presentation, Sneha. I think you tried to cover a lot, so I will ask a very basic question for your presentation. You, in the beginning, mentioned that the travel times savings can be up to 2 to 3 times,
Yes.
right? So my basic question is that why do people don't travel? Because you just mentioned some comfort issues and maybe some shady stops. Is that the only reason why they don't travel by such a fast and cheap mode?
Okay, so I can give you a few examples. Like there is a metro station present at just 600 meter from the water transport terminal, and this mode of transport in Kochi is considered to be sort of like a tourist attraction. So there are a lot of, as I had shown, 46% of the people that are using during peak tourist season are tourists. And these people are very interested to see the different forms of public transport in the city, but they are not aware of the factor of how are they able to reach these places. And I myself have surveyed a few of the tourists, so they're like, okay, we didn't know that there was a metro station present this close and we can walk to the water transport terminal from the station, because they were finding it difficult due to during peak hours. In order to reach to the station, it takes a lot of travel time by road. So if they know about the possible multimodal connectivity, they will be more open to using this mode of transport. Yes.
Public transport has a certain transfer points.
Hmm.
Water transport is not this end-to-end journey.
Yes.
There is some transport from metro bus.
Yes. So
Then you analyze how much is the transfer, how much is being transferred from others, what is the end-to-end journey done in the water transport.
So actually most of the water transport users, they are using this as the mainline mode of travel. The first and last mode of connectivity is majorly is either buses, autos, or even there are a lot of people that are using cycles. That is more of the lesser income sections of the society that are using cycles, especially on the island areas.
What is the length of the average length of the streets, lines?
Between these islands, it's around 15 to 20 kilometers, sir. And between one island to other, it takes around 30 minutes. So that's why they have given a 30 minutes waiting time for each trip. Yes.
Anyone else? Okay, thank you, Sneha.
Thank you.
Our next presenter is Shipra Verma. She'll be talking about measuring shoppers' perceived satisfaction towards pedestrianized urban commercial market space in Delhi.
Hello. Very good morning, all of you. I am Shipra Verma from IIT Roorkee. I'm a recent graduate from Masters in Urban and Rural Planning. Every time when an area is transformed into a pedestrianized zone, a city gets a soul, because the pedestrianized zone provides vivid, vibrant places. And my topic today is also related to pedestrianization. So it is measuring shoppers' perceived satisfaction towards pedestrianized urban commercial market space in Delhi. And this is my quick introduction about the content. So I'll start with introduction, then about the survey, data analysis, and then the conclusion part. So coming to the introduction, as we all know that there is a high pace of urbanization in India, and it is going to rise up to 50% by 2050. And urbanization is basically the movement of people from rural to urban areas, and subsequently there's an increase in population to the cities and urban areas, which lead to several problems such as rise in private vehicle congestion, traffic, crowding in public transportation, and as we all know in Delhi, the pollution is one of the major concern. And what I have figured out due to researching on the recent literatures, that the root cause of these problems are that our cities are not walkable. And worry not, because our government is taking some initiative to tackle these problems and trying to pedestrianize some of the commercial areas in the cities. But there is some lack. And so here my research comes into play. That so I'll be mainly focusing on the perception of satisfaction of shoppers towards these pedestrianized commercial areas. So towards that, my first objective is to drive the satisfaction ranking of attribute influencing the accessibility of pedestrianized commercial markets based on the shoppers' perceived satisfaction. So the main factors are ranking and figuring out the attributes. And the second one is to analyze the influence of demographic factors such as age and gender on the perceived satisfaction. So for taking my research further, I have taken Delhi as my area for this study. And these two markets that I have chosen, Karol Bagh and Lajpat Nagar, for my further study. And due to limited time constraint, I have chosen one city, which is Delhi, and these two markets. And why Delhi? Because Delhi has a hierarchy of commercial areas, and these two markets have been chosen from that hierarchy. And Delhi's also have a strong public transportation network, and that's why the chosen markets are well connected with the public transportation. And also finding two similar markets with comparable population and footfall and commerce and popularity in another city is quite difficult. And being a national capital, Delhi has a unique visitors to these markets, and these two markets are also renowned market in Delhi, according to the tourist department, the Delhi Tourism Department. And so these are the two study areas that I have chosen. So these both of these areas are well connected with public transportation. As you can see, 1 minute walk to 6 minute walk to the metro. And for Lajpat Nagar also, both of the nodes, the public transportation nodes, are in the 300 and 600 meter circle. And coming to the selection of attributes, so the selection of attributes done on the basis of frequency analysis. So these are the 8 attributes that I have chosen for my study by studying the literature. So first one is the safety of the shoppers from vehicle security, comfort from the harsh weather condition, as Delhi has subsequently a harsh condition in summer and the winter time, and the universal accessibility, social life, lighting, cleanliness, and aesthetics. And for that, questionnaire was prepared using these attributes, and a 5-point Likert scale was made for the survey. And the survey was made into 2 languages, Hindi and English. And the mode for data collection was tablet-based, pen, paper, and online survey using the scanner. And so the collected sample was 400. And for determining the sample size, we have used Cochrane's formula, and the minimum sample size came out to be 384. So the collected sample is more than that. And for the reliability of the collected sample, Cronman alpha was used, and the value came out to be 0.784. So in Cronman alpha, the value should be between 0 and 1, and the closer it is to 1, the reliable the results is. And these are some of the pictures that I have taken while surveying. And so now the data is collected. Now I have to figure out that what method I can use for the further study. So I have chosen TOPSIS as a method because this is the method which is suitable for collecting ordinal data for Likert scale. And this is the best for ranking the alternatives. And it is what basically it does that from TOPSIS we can figure out the ranking of the attribute by involving it to the ideal solution and the worst solution. And for data collection, we try to take equal number of male and female respondents for unbiased and equitable results. And as you know that Delhi has a diverse range of visitors in these markets. So 95% of the population is local from Delhi and NCR region, and 5% are from different states and even countries. And the age, so around 20% of the visitors are under age of 40 years, and around 80% of the visitors are above 40 years, as these markets are famous for trendy and modern designs of clothing. And the main purpose for the shoppers visiting these markets are shopping and then socializing, eating, because these markets are, especially Lajpat Nagar, is very famous for eateries. And yeah, there are some violations that are seen in the markets. So basically, pedestrianization means the complete restrictions of vehicle from a particular zone or a street. So, but there are some violation that has been seen in these markets. Example, entry of vehicle, littering, and theft and vandalism cases have also been found. And coming to the data analysis for TOPSIS. So in TOPSIS, this is the table of ranking that has come out for all the 8 attributes for the entire data for 400 samples. So in this, the closer it is to the ideal solution, which means the lesser the positive distance, the higher the ranking of the attribute is. So safety and social life came out to be the attributes which with the higher ranking. As safety, because the vehicle, there's a restriction of vehicle in the area, so comparatively the ranking, the safety has improved. But on the other hand, universal accessibility and cleanliness is the problem, as you can clearly see from these pictures. There's a lack of the garbage bins in the area, and littering all around, even in the parks, and uneven surface. And so for this data, I have divided the data into male and female also, to check whether what are the ratings according to the gender. So for female also, the safety and social life came on the first and second ranking, while the universal accessibility and cleanliness are the factors which lack the satisfaction of the people. So as you can see, the benches have been installed, and the less number of vehicle, and for the ranking of attributes for male respondents, the comfort and social life are the factors which are at the top, as the benches have been installed and now they are more comfortable while roaming around in the market. Again, the cleanliness and universal accessibility for the male respondents as well is a huge problem. Coming to the attributes for ranking of the attributes for the age group. So above 40 years, comfort and social life has improved as the branches have installed, and now the elderly people, they can come to the market and they have some resting places. Again, in both of these cases, the universal accessibility and cleanliness is a huge issue. And also, as you can see in figure 10, the ramps that they have in the markets are improper, and there's no railing. And in most of the places, there aren't even ramps or the tactile flooring for the disabled or elderly. And coming to the conclusion part now. So according with the exploration, with our exploration with TOPSIS method, it really helped us understanding what are the attributes with shoppers are happy and sad with, and it came out to be really suitable for this analysis. And secondly, safety is a big hit, because most of the shoppers are satisfied with this aspect, while on the other hand, the cleanliness still needs a lot of improvement in these areas. And for the urban authorities aiming to boost these commercial centers, here are some of the key takeaways. So for cleanliness, quick action need to be taken for these crucial issue. Regular checkups and inspection are essential to create a clear and more satisfying environment. And for universal accessibility, there's a huge issue. So let's make this center open for everyone. Wheelchair ramps, clear signage, uncluttered pathways are a start. And why not add some comfortable sittings and enough seating for everyone, and accessible washrooms, parks for children, and wheelchair rentals. And in a nutshell, by paying attention to these points, we can make visitors happy and create a commercial centers that welcome and inclusive to all. And together we can shape these spaces that are truly resonates with our society and community. And these are the references that I have used. And in the end, God made us walking animals, pedestrians. As a fish need to swim, a bird to fly, a deer to run, we need to walk. not in order to survive, but to be happy. Thank you so much for giving me your time.
Anyone has any question, he can ask.
Yes. So I've taken the survey in which I have asked this question about the violation to the shoppers, and from that it has come out. Yes, I have asked them. Okay, thank you.
I think there are no more questions. Thank you, Shipra. Our next presenter is Samruddhi Gujar. She'll be presenting her work, Quality and Performance of Passenger Ferry Service. Yeah, it's working. You can check.
Good morning, all. I just recently graduated from SP Bhopal and I completed my master's in transportation planning and logistics management. Today, I'm here to present my topic on passenger ferry service levels. The presentation will follow in few steps. Where first I'll explain the need of the study, followed by the parameters selected to study, then the introduction of the site where the location and the survey done will be discussed. The collected survey will then further lead us to the data analysis for the two based on the two perspectives, operator and passenger perspective, followed by the level of service parameter measures which have been calculated for this study, and the presentation will end with few recommendations for the same. So why do we need this study? So when we talk about the inland water transportation, which is passenger centric, on the global perspective, there are few. It only addresses to the few sectors of the research, that is operations, management, infrastructure, demand, fares, and policies. For India, there are National Waterways Act and Inland Waterways Authority of India, who has designated national waterways, who only looks looks into the operations and management of the logistics services, and connects the few vital linkages between the water separated by the water channels. But there are no evaluation techniques based on the level of service concept for the Indian cities. So this study will be based on the case city of Mumbai. To further analyze on the level of service concept, first we need to understand the current scenario of the ferry service which is available in the Mumbai city. For doing this, there are 5 parameters which have been selected. First is individual preference of daily and non-daily users. This parameter will help us understand the ferry usage, and it will help us to know the choices made by the users for preferring the ferry services. Second is connectivity to public transport. This parameter will help us understand how the people travel from the ferry to reach to their destinations and from their origin to their ferry terminal. Third is ferry patronage. This will help us understand the demand at the ferry. Since the studies done in the Mumbai city, climate plays a very important role in Mumbai city for the water transportation sector. So the safety and mode choice based on the climate will also be seen. And finally, the management of the ferry service, the financial condition the profit or the loss made by the ferry operators will be studied. These 5 parameters will help us understand the current scenario of the ferry services. Further to assess the LOS of the ferry services, there are 9 parameters, and out of the 9 parameters, based on the literature review, 5 parameters have been selected. So starting with the travel time. Travel time is studied to understand the travel time will be studied with respect to the automobile travel time, and so that the captive users do not shift to the alternate mode of transportation. Second will be frequency. User satisfaction with the current frequency will be studied, based on which the LOS will be designed and calculated. Third is cost, that is ticket fare of the ferry is understood, where the willingness of the users to pay the fare which has been suggested by the operators will be studied. And fifth is the passenger comfort. The comfort levels of users using while traveling the ferry will be assessed based on the environment of the ferry, environment of the pier infrastructure, the cleanliness in the ferry and around the ferry. And lastly is the vessel capacity, where the crowded the capacity based on the crowdedness of the ferry will be studied, and if there is a requirement of new vessels or not. Coming to the introduction of the city, so the selected city is Mumbai, where the operations are provided by the MSRDC, that is Maharashtra State Road Development Corporation. Total 20 ferry routes operate in and out of the Mumbai city with 25 ferry stations, and all the ferries have been operated by the private operators. These are sublet by the MSRDC. When we look at the infrastructure part of the ferry terminus, it is looked by the MMB, that is Maharashtra Maritime Board. Coming to the survey locations, out of 25 ferry routes, here total 8 ferry routes are been studied, which terminate from the 4 ferry terminals within the Mumbai municipal boundary on eastern and western coast. So Ferry Wharf, Gateway of India, Marve Jetty and Gorai Jetty are the ferry locations where this survey was conducted. Primary survey was collected based on the user survey where questionnaire format was used, and for understanding the operator perspective, informal interview type was been taken. Total samples collected of passenger survey are 157. Starting with the data analysis for operator perspective, if we look at the types of users, there are 3 types of users which have been which came out from the survey, that is daily, non-daily and tourist. From all the 4 locations, if we see, maximum number of daily travelers are using the ferry services, followed by tourists and then the non-daily travelers. Coming to the types of purpose, the ferry is been used by for maximum for the 4 types of purpose, that is work, education, recreation and shopping. From all the 4, mainly the ferry is used for work and recreation purposes. Coming to the data obtained by the obtained from the operator, if you look at all the 4 locations, so we the data will let us know the total operators who are providing the services, the total launches which are available, capacity, and the if you look at the below 3 rows, there is fare, ridership and frequency. So the fare, if you look for the one side, is varying in a very vast vast range from 100 to 15. This is because of the time that they take, total time that they take to travel from one ferry location to the another ferry location. Since the fare where the 15 rupees are collected, the travel time is 15 minutes, and where 100 rupees are collected, the travel time is 1 hour. Coming to the further data analysis, where the financial mechanism is calculated. For this, the 3 factors are kept constant, that is fuel cost, salary and maintenance charges. If you look at the daily tickets sold, there are 300 daily tickets sold with the 100 rupees of ticket fare. Out of 100 rupees, 10 rupees goes to the MMB for the infrastructure needs, and the daily fuel cost which they require are 95 rupees per liter, and the fuel consumption by them is 35 liters per day. So if we do the further calculations from the operator survey, we understand that the profit that they incur is rupees 30,000 monthly, and if you look at the total daily revenue, that is 80,000 250 rupees that they incur. So if we monthly. So if we look at the profit that they make monthly, this is not sufficient for them to make the changes based on the based on the infrastructure or the new services, or to improve the ferry services of their terminals. Coming to the connectivity to the nearest public transport, if we look at all the 4 locations here, from the graph we can see that maximum at the ferry location Ferry Wharf and Gateway of India, maximum ferry location, maximum users use bus and cab services from the ferry terminal to reach to their destinations. Since these bus and cab services are are available right in a very minimum distance from the ferry terminal. And if you look at the Marve and Gorai Jetty, here the maximum number of people are using 2-wheelers to reach to their destinations, since the reason being the ferry allows 2-wheelers inside the ferry, and so it becomes easier for them to travel from their home till the destination. Coming to the individual preferences of daily and non-daily users, here we can see that the reason why users are choosing ferry service as a mode is maximum because travel time is less than the travel time by the road, and it also becomes and for 2 areas it also is because of the it is only option available for the commuters to use the ferry services. Coming to the conditions during monsoon season, here we can see the safety issues plays a major role, due to which people are not using the ferry services, and most of the travelers who are daily users, they are aware of the schedule, and since they adjust their travel time accordingly. Now coming to the level of service parameter measures, so the 5 parameter measures on which the service is calculated. So starting with the frequency, here the number of samples are reduced to 126, and excluding the tourists, since the tourist samples were giving us the undefined survey results, but the level of service cannot be included, the tourist samples. That is why the tourist samples have been excluded. Coming to the frequency is calculated based on the satisfaction levels, that is the percentage of riders satisfied with current frequency provided. From the primary survey collected, these data, the categories have been designed based on the primary survey and from the passenger perspective, and the following table has been designed. The LOS categories are distributed from A to F, A being the best and F being the worst, and based on for all the 5 parameters, different variables will be used to design these parameters. So for frequency, satisfaction levels was calculated, where A is 100% riders are satisfied, B 80 and above, C 60 and above, D 40 and above, E 20% and above, F is 0% and above. Coming to the travel time, the variables used to assess the travel time and design the level of service categories are the travel time from the origin to reach till the ferry terminal, plus the waiting time at the ferry terminal, and plus the travel time to reach to the destination. Total time is calculated, and the travel time has been is compared with the automobile travel time, where automobile travel time. So based on the ferry travel time divided by automobile travel time, further categories have been designed, A to F. Coming to the ticket fare is also compared with the operating cost, since travel time and ticket fare are 2 factors based on which the captive users can shift to the alternative mode of transportation. So it was necessary to compare them with the automobile travel time and operating costs. So similarly, ticket fare is been compared with the operating cost for the same distance that they are traveling, and based on the data obtained, the following A to F categories have been designed. Fourth is the passenger comfort. Here the satisfaction levels based on 5 factors have been collected, and the mean average of these 5 parameters is been calculated. Cleanliness in ferry, cleanliness around the pier, sitting comfort, operators behavior, and crowdedness in ferry. Based on this, the mean value is generated, and for that the LOS category is been calculated and designed. Lastly is the vessel capacity, where the person capacity of the vessel is been calculated, where passenger plus vessel divided by the full capacity will give us the person capacity of the ferry vessels that are being used at those particular locations. Further, till now we have 5 LOS parameters on taking ahead which the improvements can be made. But how will we understand that which parameter or in which sector the improvement needs to be done first? So for that, the analytical hierarchy process has been used to rank these 5 parameters. An expert opinion was taken for these to rank these 5 parameters, and based on that, the final ranking gives us first frequency, travel time, ticket fare, passenger comfort, and vessel capacity. These ranking will help any stakeholder public any stakeholders to understand that after calculating LOS, which parameters first needs to be taken care of. So coming to the recommendations, as we saw, the monthly profit is of the operators is 30,000 rupees. So there are few recommendations that can be done from the operator's perspective. First is they can start by providing charter services, where they can incorporate, since it is working at one of the ferry locations, it can be incorporated on other locations too. Second is advertisement and sponsorship. The ferry space can be utilized and the vessels can be utilized for the advertisement purpose. This will let them generate the advertisement revenue. Third is tours and excursions. They can collaborate with the local tourism organizations and attract the additional customers based on these tours. Coming to the LOS that has been designed, first recommendation would be to form a specific administrative department to overlook ferry transportation of the city that has been surveyed. There are a few 6 steps that can be used or can be upgraded as per the need of the city and as per um, the aim of the city that they need to do. First, they need to decide the parameters based on which the LOS will be calculated. The data should be collected for those 5 parameters. The LOS categories should be set. Ranking should be given, and then the financial mechanism should be checked, and finally the improvements. If we look at the LOS categories, those LOS categories can be changed or added or subtracted based on the requirement of the city and where the survey is been done and based for the desired outcomes. The survey questionnaire can be upgraded based on the parameters which are fixed, and it will be recommended to take a quarterly or season-wise data that will give us the more a clear view on the change in the ferry services which have been provided, and the financial mechanism will let us know if there is a need for the new funding source, or the miscellaneous revenues need to be generated for the particular city. Thank you.
Thank you.
Thank you.
So the floor is open for discussion. Yeah, we can take two questions, shorter questions in the interest of time. Yeah. If anybody has any question. Okay, thank you. We'll move on to the next presentation. It'll be presented by Sabida Rakra. Paper ID 61, paper title Parameters for Assessing Public Transport Accessibility of Indian Cities.
Good morning, everyone. Myself, Savita Lakra. I'm a recent graduate from SPA Bhopal. So today I'm here to present my work on parameters of assessing public transport accessibility for Indian cities. So here, studies suggest that public transport can be enhanced or improved by improving its accessibility. There are various tools available to actually to assess or evaluate the accessibility of existing PT system. One such tool is PTAL, that is Public Transport Accessibility Levels. It was developed in 1992 and was adopted as a standard method for evaluating the existing PT system in 2004 by Transport for London. Later, it was adopted by various countries across the world. It uses 4 parameters, that is point of interest, origin of the trip, service access point, which includes bus stops, metro stations, railway station. Then the walk network, that is the walk which connects the point of interest to the nearest SAP, and the service of the frequency provided at each service access point. But literature here proves that there are various other parameters as well which actually impact or influence the accessibility of public transport system, which may include fare and time to land use to population density, etc. One such study conducted in Melbourne region shows that there is significant difference between the observed and the expected PTAL. So there must be some parameter missing up there. Also, when PT system is considered in India, a study conducted by Mahua in 2013 showed that most of the PT users are actually the captive users and not choice users. Still, the accessibility assessment has been carried out for only a few metropolitan cities. So my study aimed to actually identify a few more parameters that can be incorporated in the existing standard tool. Okay. So this was the methodology followed, that is to firstly understand PTAL and its parameters, then to analyze the gap between the observed and the predicted PTAL values, and to identify few more parameters that could be added up. This is how a standard PTAL is developed. It includes 6 steps. That is, firstly, to allocate the point of interest and service access points, then to calculate the the time taken to reach the nearest service access point. That is the average. Then add on the average waiting time at the service access point. Sum up both to get the total time taken, and the EDF. EDF is actually equivalent doorstep frequency. That is, if the service is provided right at the doorstep, what are the chances and how easily I can access the public transport system. This all is then summed up to get AI, that is accessibility index, which is then showed in the map using GIS. So the secondary studies show that there are these following parameters that can be added up. Operational are the ones which are actually used in the standard system right now. There are other parameters, that is population density, land use, temporal parameters, that within a day how a PTAL would change. Then universal design, availability of infrastructure and services, affordability, level of service, safety, and cleanliness. However, the significance of these parameters is identified. Its incorporation in the tool or how it will be utilized is not yet explored upon. So for this, I selected 3 sites on the basis of population, area, and availability of structured PT system. So my 3 sites were Rewa, Satna, and Singrauli. All the 3 falls on the eastern part of MP, with population less than 5 lakhs and existing public structured PT system and IPT system running along the same route. So for data collection, from all the 3 sites, a 3-day survey was conducted on each of the site, where the secondary data was collected from mostly from the Nagar Nigam, and the primary data included one observational survey and a perception survey. In the observational survey was conducted at the station and in the vehicle, and perception survey was carried out both for the PT and IPT users. So here you can see the existing condition of the infrastructure available in all the 3 cities, where mostly the infrastructure is either encroached or not available. From the perception survey, it was found that the PT users actually opt for the service due to its lower fare prices, whereas IPT users are mostly opting for the IPT service due to its easy availability, that is easy boarding and alighting facility along the route. Then standard PTAL was developed for all the 3 cities. Here we can see in all the 3 cities the PTAL is very poor. That is, the blue part is the poor region. So now the question is, why is it so poor? These poor PTAL values is because when we develop a standard PTAL, the whole of planning area is considered, but there is no built up in those areas, and providing PT service or any of the services where there is no built up is of no use. So here a layer of built cover was added into the standard tool, so that only the areas which have existing settlement and requires public transport or IPT system is taken into consideration. So here we can see the values of PTAL. The PTAL values are a little more better than the previous one, which was yielded from the standard tool. But if we just consider the built cover, it is basically considering an hectare with 10 households and a hectare with 100 households equally. So why not to add a layer of density into it? So the density of the river city was again divided into three, that is low, medium, and high density. And PTAL was developed for all the three densities separately. So here we can see that as the density increases, our PTAL values are also improving. This basically shows that the PTAL or the accessibility is directly proportional to our densities. But here again, if we just consider the densities, we are basically considering an area which is less trip generating or trip attracting, equivalent to the one which is having more trip generating possibility. So we can even add another layer of land use into it. So three major land uses were considered, that is residential, commercial, and institutional, and PTAL was developed again for all the three land uses separately. So here it was found that public transport is still less accessible to the entire city for different land uses as well as compared to that of IPT. So here is the conclusion of how these additional parameters can be incorporated in the standard tool. First of all, to generate point of interest only for the built cover and not for the entire city. Then at the second step, that is allocating the service access point, SAPs, IPT stands can be also added up along with bus stop, railway stations, and metro stations. Then the calculation of AI will remain same, but later on, and building density and land use can be incorporated as an additional parameter, and we can develop a new PTAL from it. So the standard PTAL tool only provides us the accessibility of the area, whereas the revised PTAL tool can also provide the priorities of the areas, that is combining the density and land use into the standard tool. Furthermore, these priority areas can be utilized to identify can be used to identify the areas which would require and which would require a public transport or IPT system, whereas and that can be compared to an area which has lower density or land separate land uses. And to ease down the process, a GIS plugin tool can be also generated. That's all. Thank you.
Yeah, thank you, Ms. Savita, for the interesting presentation. Now the floor is open for discussion. If the audience has any questions, you can ask. Yeah, person.
Good presentation, Savita. I have a fundamental doubt. This is regarding the point of interest you have chosen for the analysis. So when you're saying the origin of the trip, how did you identify the origin of the trip? Did you have, like, it is through surveys, or what was the access to the data? What is the data you have used?
So the standard tools actually suggest that we divide the whole of our planning area into smaller grids, and the centroid of each grid is treated as point of interest. So here, the standard tool also says to take square grids, but the PTAL, which was developed for Delhi, suggested that we can consider hexagonal grids instead of square ones. So I have taken the hexagonal grids, and centroid of each grid is then taken as point of interest.
Thank you.
Are there any other questions? Okay.
Otherwise, there is a survey, there are taken the data which shows but in case of the means city operation, there is no public transport available, and I have to decide certain routes, design certain routes for the villages. What was the criteria of defining this grid? Is there population, is there population center? How do you?
So if there is no existing public transport system, if we
Your method which is suitable for those cities where there is no public transport.
so
Because
if
there is no origin point as such, we are estimating.
So this can also help in estimating. If we consider only the density and land use, and we overlay both of the layers together and find a way to calculate and actually get those priority areas where the density is high, and we see commercial areas have high trip generating potential. So we can club those two. We can find the we can also use that to identify where we can have the bus stops or metro stations placed. Yeah. So for bus stops, for metro stations it is 400 to 500 meters. For bus stops, I have taken 150 to 200 meters.
Are there any other questions from the audience? I have an observation or rather a question. In the waiting time calculation, it's typically half of headway. Plus, I see a K in your expression. Average waiting time. What does that K represent?
K is actually the reliability factor.
Sorry?
Reliability factor.
Reliability factor.
Yeah.
How did you arrive at that factor in your calculation?
So I have borrowed it from the studies conducted in Surat and Delhi.
Okay.
Reliability factor is actually if I'm promised that I will reach my destination in 15 minutes. So I should be reaching there in 15 minutes. If that is delaying even by a minute or two, so that will hamper my reliability.
Okay, then how do you, and somewhere I see calculation on reliability as well. Is the data coming from the user side? You had some user perception related data went into this.
No, for this study, I have borrowed it from the literature studies.
Literature study, okay. And my other question is, what is the broader concept of accessibility here? It's a distance-based concept, time-based concept, or a composite of all? How do you conceive accessibility here?
It is actually composed of both time and distance because.
Okay. But in these times, physical challenge, physical ability is a factor. Money is a factor. Gendered nature, several things are going into the accessibility concept nowadays. So I'm just wondering, would you whether you had considered that aspects into your study, or you just stay with the distance, or the conventional way of looking into accessibility is the distance or time in general. So I'm just trying to understand from you. Did you look into those aspects, or just stay with the convention?
So I have identified those parameters as well, where fare, time, land use, universal accessibility, cleanliness, safety and security. These parameters are also there, but to include, due to time constraints, I could include only 3 parameters into the tool, right?
Okay, great. Thank you.
Thank you.
Thank you, ma'am. We'll move on to the next presentation. The last presenter is Sanya. Sanya is here. Paper ID 48. I think she's absent. If that is the case, we are concluding this session. So we had 5 presentations today covering various themes of travel demand modeling as well as transport planning. And I'm thankful to all the authors who presented their work here, sharing their valuable research insights with us. And I'm equally thankful to the audience who engaged the presenters with thought-provoking questions. And with this, on behalf of this UMI RS team, Research Symposium team, once again, I thank you all. And I'm saying that, the session is concluded. We break for tea. And then, you can interact with the, audience as well as the presenters for a long time. Okay, thank you all. Have a nice day.
Thank you so much for being here for the UMI 2023. To end the session, I would like to present on behalf of UMI a token of appreciation to the chair, Professor Manoj M. Sir, I would like to invite you to the.
Okay. Thank you.